This is the tutorial for the application layer. The application layer is the topmost layer of the TCP/IP protocol stack, and it is responsible for providing services and protocols that allow for application communications. This layer provides a standardized interface between the network and application, allowing them to send and receive data in a format that can be understood by other applications. The network applications, which programs, run on the various end systems and enable communications between the end systems. Web application is also one of the most well-known examples for it. In our day-to-day lives, we use a variety of internet programs for tasks, including web browsing, email, multiplayer online games, and conference calling, and also file sharing. Some programs are simple to use since we use them without understanding how they operate. The interface in the TCP/IP model that gets a communication ready for transmission over computer network is called the application layer. It includes a client-server architecture, a system that hosts, provides, and manages the majority of the resources and services. When the server receives a request for the data from the client, it complies and transmits the requested data packets to the user. Server is always on host and has a fixed IP address. Client have dynamic IP addresses, can always send packets to the server. Client indirectly communicates with other clients. Examples include web applications. Protocols used in the application layer. There are several protocols that are used in the application layer that include HTTP, FTP, SMTP, DNS, and Telnet. These protocols provide a standardized method of communication between the application and ensure that the data is properly formatted and error free. HTTP. HTTP is Hypertext Transfer Protocol and it is used by the web browsers to communicate with the web servers. It allows users to request web pages and other resources from web servers and receive them in a standardized format. HTTP is a request response protocol where the client sends a request to the server and server responds with the requested information. This protocol is used by millions of websites and is the foundation of the World Wide Web. FTP. FTP is File Transfer Protocol and is used for transferring files between the computers. It allows users to transfer files from one computer to another in a standardized format. FTP is a client server protocol where the client connects to the server and requests to transfer files. The server responds by either accepting or denying the request and then proceeds to transfer the file. And FTP is widely used for file sharing and is an important tool for businesses and organizations that need to transfer large files over a network. SMTP, Simple Mail Transfer Protocol, is a protocol that is used for sending emails over a network and allows users to send and receive emails in a standardized format. DNS is a protocol used for resolving domain names into IP addresses. Domain names are easy to remember and are used to identify websites and other resources on the internet. However, computers communicate with each other using IP addresses, which are a series of numbers that are difficult to remember. So, DNS provides a way to translate domain name into IP addresses, making it easier for users to access websites and other resources on the internet. Services that are provided by the application layer: data representation, encryption, and compression. Data representation is the process of converting data from one format to the another. An application layer provides a standardized method of representing data, ensuring that the applications can send and receive data in a format that can be understood by the other application. It is essential for applications that need to communicate with one another. Encryption is the process of converting data into a form that can only be read by the authorized user. The application layer provides several encryption protocols that includes SSL and TLS and that enables the application to send and receive data securely. Compression is the process of reducing the size of the data to make it easier to transmit over a network. The application layer provides several compression protocols such as gzip and deflate that enable applications to compress data before sending it over a network. Application layer interfaces include sockets, APIs, and middlewares. Sockets are standardized method of communication between applications over network. They provide a way for application to send and receive data in a standardized format and are used by many applications including web browsers, email clients. APIs. Application programming interfaces are a set of programming instructions that enable applications to communicate with each other over network. They provide a standardized method to communicate between applications and allow developers to build applications that can communicate with other applications using a standardized interface. Middleware is a software layer that sits between the application layer and the lower layers of the TCP/IP protocol stack. It provides a standardized method of communication between applications and enables applications to communicate with each other regardless of the underlying network technology. It is essential for applications that need to communicate with each other over a wide variety of networks and devices. DNS. It's a critical component of the Internet, responsible for translating human-readable domain names into machine-readable IP addresses. DNS records, messaging, caching, and queries are all essential of the DNS system, allowing users to access websites and services quickly and efficiently. The domain name system servers are responsible for converting the web addresses into the IP addresses. DNS records are pieces of information stored in a DNS database and provide information about a domain name. The most common DNS records include the A record, and mail exchange record, the canonical name record, and the text record. DNS messaging refers to the process of sending and receiving DNS queries and responses between the DNS servers. When a user enters a domain name system name into the browser sends a DNS query to a DNS resolver, which then sends a query to a DNS server to find the IP address associated with that domain name. The DNS server responds with the IP address, which the resolver then returns to the browser. DNS caching is the process of temporarily storing DNS records in a local cache to speed up subsequent queries for the same domain name. When a DNS resolver receives a response to a query, it stores the record in its local cache for a specified period. The next time a query is made for the same domain name, the resolver can retrieve the record from its local cache instead of sending another query to a DNS server. That speeds up the process. DNS queries are requests for information about a domain name. When a user enters a domain name into the browser sends a DNS query to a DNS resolver, which then sends a query to a DNS server to find the IP addresses associated with that domain name. So the DNS uses a hierarchy of DNS servers to carry out this task and maintain a distributed database with instructions on how to convert user-inputted hostname into pertinent IP addresses. The DNS protocol uses client-server architecture to enable communication between various end systems. DNS server used by application to obtain the hostname, canonical hostname. DNS helps in load distribution and is not centralized to avoid a single point of failure, traffic volume, or high maintenance. It is not scalable so that it can be reliable and organized. It is a data DNS is a database which is distributed and hierarchical. So the order is root, top level domain, and authoritative. Client queries to find the particular DNS server. It first queries to the upper level. DNS top level domain and authoritative servers. DNS top level domains are the highest level domains in the hierarchical DNS naming system, and they are the suffixes at the end of the domain names, such as .com, .org, .net, .edu, etc. Each TLD has an authoritative name server that is responsible for maintaining the DNS records for all the domain names within that TLD. These authoritative name servers are operated by the organizations that manage the TLDs. When a user types in a domain name or clicks on a link to a website, the DNS resolver software on their device sends a query to a recursive name server to resolve the domain name. The recursive name server first checks its cache to see if it already has the IP address associated with the domain name. If it does not, then it contacts the authoritative name server for the TLD of the domain name and asks for the IP addresses associated with that domain name. This is the tutorial for transport layer. The transport layer is a part of the TCP/IP model, which is the set of protocol used for communication over the internet. The transport layer is responsible for providing reliable and efficient data transfer between the end systems, such as computer or servers. It receives data from the upper layers, adds a header to the data, and passes it to the network layer for transmission. The transport layer is implemented using two protocols, the UDP and the TCP. Understanding the role and functioning of the transport layer is essential for anyone working with the networks and network protocols. Functioning. The application processor utilize the transport services, and the messages are broken into segments by the transport protocols action in the end systems, which are the sender. And then the messages are reassembled to be sent to the application layer, which is the receiver. The logical communication between the processes taken place through this layer. When messages go through the transport layer, it determines the segment header values coming from the application layer when the messages is being sent. When the message is received, then the transport layer receives the segment and check the header value from the network layer. This is multiplexing and demultiplexing of messages. Multiplexing occurs when the message is sent, and opposite is true for demultiplexing. Messages are sent and received via the sockets. It is an API. There are two sockets on one each side. For receiving messages, there is an identifier and host device and has 32-bit IP address. Port number is also required for identifying multiple processes. Using port numbers, transport layer protocols like TCP and UDP multiplex and demultiplex data streams from several applications into a single network connection at the transport layer. TCP or UDP can mix data from both apps and send it over the network connection using distinct port numbers, such as when a web browser and an email client are running on the same host and need to communicate with their respective servers. The port numbers can be used at the receiving end by TCP or UDP to divide the data streams and send them to the appropriate applications. UDP, User Datagram Protocol, is a connection protocol that operates in the transport layer of the TCP/IP model and is used for applications that require fast and efficient data transmission but can tolerate some degree of data loss or errors. It is commonly used for real-time applications such as online gaming, video streaming, and voice over IP services. The UDP header adds the header to the data received from the upper layers before transmitting it to the network layer, and it includes the source port, the destination port, and the length field. And it also has a checksum field. The UDP header is a relatively simple and contains minimal information compared to the TCP header. It does not include sequence or acknowledgement numbers, so it makes it faster and less complex protocol compared to the TCP. However, it lacks error checking and reliable data transfer that makes UDP more susceptible to data loss or errors during transmission. The TCP, Transmission Control Protocol, is a connection-oriented protocol and operates in the transport layer of the TCP/IP model. It provides reliable and ordered delivery of data between two edge systems, and it ensures that the data is transmitted without errors, duplications, or loss. It is commonly used for applications that require accurate and reliable data transmission, such as web browsing, email, and file transfers. The TCP header includes source port, destination port, sequence number, acknowledgement number, header length, reserved field, control bits, window size, checksum field, urgent pointer, and options. It is more complex compared to the UDP header, and it ensures reliable and ordered delivery of packets. The sequence and acknowledgement numbers ensure that the data is transmitted in correct order, and that any missing data is retransmitted. The control bits are used to establish and terminate connections and to indicate the state of the connection. TCP flow control and congestion control. The TCP is a connection-oriented protocol which operates in the transport layer. It implements two important mechanisms to manage the flow of data, which is flow control and the congestion control. The TCP implements flow control to ensure that the sender does not overwhelm the receiver with too much data and too quickly. The receiver sends a window size to the sender, which specifies the number of bytes that the receiver is willing to receive before sending an acknowledgement. The sender then limits the amount of data it sends to the receiver based on the window size, and this mechanism prevents the receiver's buffer from becoming overloaded and dropping packets. The congestion control is implemented to prevent the network congestion and ensure that the network operates efficiently. The network becomes overloaded with too much traffic, causing delays, packets loss, and other problems. Then congestion occurs. TCP uses a variety of algorithms to detect and respond to this congestion, which includes slow start, congestion avoidance, and fast retransmit. And these are some of the algorithms that is used by the TCP, which is the slow start, congestion avoidance, and the fast retransmit. This is the tutorial for network layer data plane. The network layer is part of the TCP/IP model and is responsible for routing and forwarding data packets between different computer networks. It provides a logical addressing scheme for devices on network and allows them to communicate with each other regardless of the physical location, and is responsible for managing the flow of data traffic and ensuring that the packets are delivered to the correct destination. IP is an important component of network layer and provides addressing and routing mechanism for data packets, and it assigns each device on a network a unique IP address and is used for identifying the device and determining its location on the network. When a device on one network wants to send data to a device on another network, the data is broken down into packets and sent to the destination address using IP. Each packet contains a header that includes the information such as the source and destination IP addresses, the length of the packet, and the other control information that is used by the routers to forward the packet to its final destination. As it travels across different networks, it may pass through multiple routers, each of which examine the packet header to determine where to forward the packet next. One of the key functions of the network layer is routing, which involves determining the best path for a packet to take it as it travels through the network. Routers use routing table, which are collections of network addresses and associated routing information to determine the next hop for a packet. When a packet arrives at a router, the router examines the destination IP address in the packet header and consults its routing table to determine the best path for the packet to take to reach its destination. IP version 4 addressing and IP datagram. The IP version 4 addressing scheme uses a 32-bit address space and allows for 4.3 billion unique IP addresses. They are divided into two parts: the network ID and the host ID. The network ID identifies the network to which a device belongs, while the host ID identifies the specific device on that network. The IP datagram is the basic unit of data transmission in the network layer and consists of a header and a payload. The header contains information such as the source and destination IP address, protocol type, and the time to live value. The payload contains the actual data that is being transmitted: routers, routing, and switching fabric. A router is a device that forwards IP datagrams between networks and has multiple input and output ports and uses switching fabric to route data between them. The input port receives datagrams and the routing table is consulted to determine the appropriate output port. The switching fabric is used to forward the datagram from input port to the output port. Routing is the process of forwarding IP datagrams from one network to another, and it involves the determining the most efficient path for the datagram to travel. It can be done either statically, where the routing table is manually configured, or dynamically, where the routing table is updated automatically based on the network conditions. Switching fabrics are used for connecting the input and output ports of a router, and several types of switching fabrics include shared memory, shared bus, and crossbar. Shared memory fabrics are common memory buffer to store incoming data, while shared bus fabrics uh, use a common bus to transfer data between ports. Crossbar fabrics use a matrix of switches to connect each input port to each output port. Input and output ports in a router. In networking, a router is a device that forwards packets between the different computer networks. Each port on a router is typically assigned to a different network or a subnet. The input port on a router is responsible for receiving packets that are destined for one of the networks connected to that port. When a packet arrives at the input port, the router examines the destination address in the packet header to determine where the packet needs to be forwarded. The router then looks up the appropriate entry in the routing table to determine which output port to use for forwarding the packet. The output port on a router is responsible for transmitting packets to the next hop on the path to the packet's destination. Once the router has determined the appropriate output port for a packet, it sends the packet to that port for transmission. The output port then transmits the packet onto the network that is connected to. Routers can have many input and output ports depending upon their size and capacity. Large enterprise level routers can have dozens or even hundreds of input and output ports, while the small home routers may only have a few. In addition to input and output ports, routers may also have a specialized port for connecting to the other types of networks, such as WAN, wide area network ports, or serial ports. WAN ports are used to connect to the external network, such as the internet, while the serial ports are used for connecting to legacy devices that use serial communication protocol. Subnetting. It is a process of dividing a single network into smaller subnetworks called subnets. Subnetting is a common practice in network design and is used to improve the network performance, security, and manageability. It allows network administrator to create smaller, more efficient networks that are easier to manage and troubleshoot. It is done by borrowing bits from the host portion of the IP address and use them to create a subnet mask. The subnet mask is used to divide the IP address space into two parts, the network portion and the host portion. The network portion identifies the subnet, while the host portion identifies individual hosts on the subnet. For example, consider the IP address 192.168.10/24, where the slash 24 indicates the first 24 bits of the addresses that are used for the networking portions, and the remaining 8 bits are used for the host portion. In this case, there are 256 possible IP addresses, or 2 raised to 8 on the subnet, ranging from 192.168.1.1 to 192.168.1.254. By borrowing bits from the host portion of the address, a network administrator can create smaller subnets and fewer IP addresses. It has many benefits, such as improvement in network performance, network security, network manageability. And it can be done using a variety of subnetting techniques, including variable length, subnet mask, and classes, inter-domain routing. Variable length subnet masks allow a network administrator to create subnets of different sizes, while CID allows a network application to allocate IP addresses space more efficiently. Cisco Packet Tracer is a network simulation that allows users to design, configure, and troubleshoot network topologies in a virtual environment. It provides a range of devices that can be used to create a network topologies, such as routers, switches, hubs, firewalls, and wireless access point. It allows the support of a variety of network protocol and services such as the DHCP, DNS, NAT, OSPF, RIP, VLANs, and VPNs. Additionally, it supports collaborating among multiple users, and changes made by the one user are reflected in real time for the other user. It is widely used in networking courses and certification programs and is an invaluable tool for the networking administrator engineer.